Hi to FNC Maps hands-on. Let me just preface this video a little bit differently. This is an idea I had for a couple of weeks to show you guys how you can use TMS products, certain controls, certain component packs, how you can use them for real-world cases. Obviously, I have written one book already that shows you how to use TMS controls hands-on, and I'm currently working on a book for FNC Maps. So it's kind of obvious that I'm into the matter right now, and I just developed this example that uses markers, clusters. If you're uncertain what clusters are, you'll learn about them. And everything is based on a database. So let me show you the database, and this is where we already go a little bit differently. Normally I cut the video so you don't see the transitions, you don't see me changing the applications. This is all hands-on. This is a little edited. This is more me showing you something as if you were doing it yourself. And the best thing is, because I need a little bit longer, you can do it at the same time as well. As we're a little bit more informal, I also leave most of the time my taskbar in here. You can see exactly what I'm doing. Let me introduce you to the finished example before we even start building the example. This way you can decide if this is relevant to you or not. I created the application in Delphi 10.4, which now has an excellent patch 2 out there, so all the issues with code completion that snuck into the initial release are gone. And the example is right here. It's called the incident browser, because the database that I use is a database that is provided on Kaggle. Kaggle is Google's data mining platform, so to speak. Everything is open source, so you can get data sets that are mostly high quality for data mining, but also for visualizing. And this is perfect for the example here, because I can refer to this data set and you can download the data set yourself and are able to reproduce the example. So the database that we're going to use actually contains all accidents in the United States since, and now me being European and all, I have to think, so since February 8th, 2016. And the only state that's excluded is Hawaii. All the other states are pretty much covered. And if we run this, you will see that you will learn how to build a list box for all the states. So we can select, for example, Florida, and then we can pick November 4th, 2017. These dates here are actually the constraints are calculated from the database. So I can't go before. For example, if I wanted to go to 2016 is the earliest date. So we actually set the boundaries of this date control in source code based on the data in the database. And then 2017, let's keep this date, show incidents. So it's going to show all the accidents that have been reported in the state of Florida, huge state, on, what is it, April 1st, 2017. Of course, my computer here is set to the localization of the United States. And if you grew up in Europe, you're always going to struggle with the month being first and then the date. So here you see all the accidents that have been reported in the state of Florida. And these are clusters. So what this means is I defined that a marker is supposed to be dropped everywhere where an accident occurred. And as you can see here, there's been quite a few accidents that day. And the clustering occurs if markers are close to each other based on your viewpoint on the map. So if you extend the window a little bit and zoom in a little bit more, these clusters are going to change. So you see here, these markers, if you zoom out, get clustered in here. And also the color of the clusters changes, which you can set, of course. You can define the images, which color to use. For example, red indicates it's a high number. I don't know how Google does this, how the algorithm works. Why do I say Google? Because obviously this is a Google map. So this example also uses the Google mapping service and not all the other mapping services. And that is also important to note. The clustering feature is Google only. And so this is all automatic, zooming in and seeing all those markers and everything. That is all something that you learn how to do. And zooming in even more, you see that we get additional information from the database that the police department actually indicates which area was affected by this report, by this accident report. And that makes it even more interesting to display on a map because it nicely shows all the possibilities that you have with TMS FNC Maps. Of course, the other aspects will also be focused. So let's jump right in and have a look at the database. So as a database, I decided to use a Sqlite database. And the reason yet again being, if I want to show you this example, the easiest thing to do is using a Sqlite database because you don't have to set up a server or anything else. I used the data downloaded from Kaggle as given and created the incidence table of that data. I also added a second table with all the states of the United States. So if you look at this first, let me increase the size a little bit. And this is exactly what I mean. Usually if I provide a video to TMS that is 5 minutes long, I cut out these sequences where I resize the window and everything like that. So this is all gonna be a little bit more informal for you. So the states table contains the name of the state, the abbreviation, and the so-called state code, which is 2 characters all the time. So I don't use a varchar here. Varchar means it can be up to 50, it can be up to 20. Of course, varchar is the standard type for ANSI characters or ANSI characters and not Unicode. However, with Sqlite being in the mix, we all know that what you write here doesn't really make a difference how the database handles it, because Sqlite only distinguishes between numbers and text, and I think dates. That's it. Everything else is the same thing, and it is only important, and that is the key thing what a lot of people mix up. If you want to use it in Delphi, you have to make sure that Delphi is able to interpret the data type of your column correctly. I'm going to show you that in a little bit. So here the data, of course, here are all the states, obviously 51 with the abbreviation, with the official one, and the code. This table also downloaded from the internet, various sources. So of course, Florida is FL. And why do I need this table? Pretty simple. If we go to the incidents table, that means all the incidents that have been reported. There's quite a few more fields in there. And you see, I didn't even take the time to define a length because the type is important, but not the length is important, because it's all strings or double values. And looking at the data, it takes a long time because that is something I haven't told you so far. The data contains, or the data table contains 3.5 million records. So this example really is hands-on. That means you have a real-world database and not something that is set up or artificially created or something. This is something you would encounter in a real-world scenario. So for us, important really are the start time of the incident report, the start latitude, and the start longitude, meaning that is really the coordinate where the event occurred. And then here's also descriptions about the accident that occurred. Important here again, the state, which you find right here. Here's the state with the abbreviation. So that's the reason why I have the other table. So if we want to give the user the option to choose between a state and we don't just want to offer the abbreviations, which are kind of unknown to non-US people, even in the States, living in the States for quite some time now, I sometimes mix it up. So it is much easier and much more user comfort to offer the full name of the state. And that's why we have this table that maps the pun intended, that maps the code of the state to the full state name. So the coordinates are important, and of course the start time, end time is not that important. We are always going to look at the start time, and that is the date that we're going to filter on. And that is also something interesting to know, because the start time and end time is a date time and not just a date. And that is where you can feel quite some performance issues when it comes to Sqlite, because Sqlite can't do a good comparison on this date value. So what I did is I added a field, start date, end date, with just the date values. I haven't even added a key for those, but that might be an additional thing to do, to add a key for those so you can filter on those quickly. So let's do that first. We add a key start, and we go to the field start date and click OK. The tool that I'm using right now is called Sqlite Studio. It is freely available, and that allows you to browse and edit Sqlite databases easily. In case you get started with Sqlite, each Sqlite database is a file on your computer. There is no server. The access is made possible by a DLL that you also can download from the Sqlite webpage. Very important for Delphi 10.4. Let me show you that real quick. We go back. The database stuff is being compiled into the executable. So you don't have to deploy anything with your executable, and you can still use Sqlite databases. You don't need the name of the file is sqlite3.dll anymore. That file is actually part of your executable. I don't want to show this to you right now using the resource hacker or something like that. But since Delphi 10.4, you can link the Sqlite DLL into your executable. And I looked at the source code and the configuration of FireDeck. By default, it's statically linked. So that means the Sqlite3.dll is part of your executable, and you don't need to deploy anything. Of course, you need to have the database in a separate file, usually. This database file, by the way, is 1.5 gigabytes. So the 3.5 million records really take up a lot of space. Going back to the database, the field types are pretty much what I guessed they are. So severity is a number, start time, end time is a date time value, latitude, longitude is a double value. It all is pretty clear. However, why did I pick these values? And this is pretty important, because let's try to find this in the documentation. If you go to the doc wiki, FireDeck, Sqlite, and then you should find something like here, connect to Sqlite databases, and using Sqlite with FireDeck. That is the article I want you to point you at, because there is a table, and this table is so important, I can't stress it enough. This table contains all the field data types, how they are mapped over to Delphi. So you just saw that I defined a varchar. So if we go to varchar, that becomes a ANSI string in Delphi. If I had defined, for example, a date, it becomes a DT date time, so a date time value. And the other one that I used was double. Let's look for double. Let me look here. There it is. So you could either use real, float, or double. It all becomes a DT double. Just be careful if you use something like, I don't know, if you've used Microsoft SQL Server before, you might think, oh, I'm going to use decimal or numeric. Well, that actually becomes something totally different. So be careful, look at this table all the time. I'm actually thinking about creating cheat sheet of some sort, and that would definitely help. I always have this page nearby to make sure, because the default type for SQLite, and that is, I don't know if I should call it unfortunate, but it was a big hurdle for me in the beginning using SQLite with Delphi. The default type for SQLite is text, and text is mapped to white memo. That means all your, let's call them string fields, are turned into memo fields and don't display in the grid by default, and that makes it so much more difficult, until I basically got the point that I have to name my data types differently, because SQLite does not care. For SQLite, everything is the same thing. It's a value in the database table, and the data type doesn't make a difference to it. Of course, if you use SQLite function in select SQL statements, there the types play a role. For example, you can't calculate a date value of a string, for example. That will also toss an error on the database side of things. However, you can do anything with any type on the SQLite side without running into any issues whatsoever. So very tough to understand for a lot of people that a date is actually nothing but a string in a certain format. So if you use it on the Delphi side, you have to tell Delphi how the date time is actually encoded inside of the SQLite database. So if you use it like I do it right here in the example, that you use the year, the month, and the date, then it will work. That is the default setting, but obviously there's other settings out there, and then you have to tell FireDAC how to encode date time values. So let's start by looking at the database connection to the application that we're going to build. I left out the step File, New, Windows VCL application. Obviously, we're going to build the main window from scratch. I'm not going to use my window, and I'm not just going to tell you, hey, this is this and this is that. No, I'm not going to do that. But the database setup couldn't be more boring. So I'm not going to go through that, click the component, set the properties. I'm not going to do that. The only advice I'm going to give is create a new data module, like I did here, using File, New, Other. Let's do that, File, New, Other, Database, Data Module, and add that to your project. And I named my data module DB Controller because it controls the database. It's a controller for the database functionality. And I dropped a TFT connection, which is a FireDAC connection. And I also dropped 2 queries, which I will explain while we build the user interface. So I'm not even going to go into those. Maybe Q states for the states. That is something I can explain right now, and it becomes clear right away. So the connection, we double click on it. That's something very FireDAC specific. And then I defined a connection name. Also something very FireDAC specific. Very few people use it. So when you open up your application and there is a FireDAC configuration file, you can actually simply say in your Delphi application, right here, if you look at the properties of the connection, you can say connection def name accidents, which is a name I provided, and everything else is being filled in based on the connection. Okay, so looking at the connection, here you see all the values that are tied to it. And Delphi actually defines a couple of names for you. For example, the Sqlite demos, the Sqlite demos pooled, the employee database from Interbase, all of these are defined for you. If you wonder, hey, where do I find those? Well, go to Tools, and then the FireDAC Explorer has all these predefined connections. Formally, these are called persistent database connections because they are persistent on your computer and they reside in a configuration file. And this configuration file is found in C, Users, Public, Documents, Embarcadero, Studio, FireDAC, and there is the file. It's an INI file. So Would be wonderful if we were able to click it, but here it is, open condev file. So you click here, and that is what I thought at least it was, but it's not. This allows you to open a different connection file. This won't open this one here. So the only way to copy paste this I found is to use Everything, which is a tool that searches your whole hard drive. You find it on Voidsoft, if I'm not mistaken. Everything, let's see. Everything is from Void Tools, and that tool searches your whole hard disk, and it's my #1 tool, I gotta be honest. So here I can type the fire DAC, and let's see what it was called because I always forget. FD connection devs. So FD connection devs, and here you see the ini file in the fire DAC directory. We open this up, and there you see FD connection desks.ini, the encoding, and then here is all the database connections. I'm not going to scroll down because there might be a password in there. That is a big downside of these things. So always remember, if you enter passwords into your database connections, the passwords are going to be in there. And so you might use this for development purposes, but to deploy it on a customer system, I don't know. I mean, it's no secret that sysdba master key is the standard default for the employee database, but for other databases you might have in your company, I don't know if you want to use this ini system. Of course, I can't go into this. FireDAC has a mechanism that you can load your connection before from this ini file, or you can, of course, like any other class, you can define your connections objects using your own mechanism. But for development purposes, this is perfect because I set up my accidents database. It's in ddataaccidents.db. And one thing, I always change the locking mode to normal, because otherwise your database gets locked when Delphi opens it, and as it's a file-based database system, your database tool can't access the file at the same time. That leads to strange errors. So, and that is one of the things I wanted to point out. Even though it's set to exclusive here, you still have the chance, if you go to your connection in Delphi, double click, you still have the chance here to make modifications to what is being set in the configuration file. That gives a nice way of configuring things generally, and then in your application you can still choose something that is more particular, more up to the point. So that is #1 for database connectivity. So if you set it up here, it's going to be stored on your computer. You have to restart the Delphi IDE Red Studio to pick up any changes. The changes are being read when the IDE starts. So you only see the name of the stuff that you created if you restart the IDE. And then it's really as simple as clicking on the connection definition name and making the changes, the individual changes. So I picked locking mode normal. Another very important thing for SQL databases is the journal mode. Journal mode is tied to transaction support, that the database creates a journal of all the actions that you take, and then you can undo certain steps. Of course, this is a feature you might not want to miss in some cases, but for this case, I don't need it at all. I'm all about performance to get the data from the database. I'm not making any inserts, so it's not that important for this application. I still set it to off because I don't need it. It will make a huge difference if you make inserts into a database. If you leave journal mode on, and for example, in another database, I had over 1 million records, and I sent insert statements or update statements. It took many minutes to do these requests, because if you look in the Explorer window of your Windows system and look at the folder where the database is in, for each thing you do, the database creates this journal, and it takes a long time. If you disable the journal mode support, these statements are going to be very quick, and the action that took minutes now takes mere seconds. So sometimes these settings can lead to huge performance boosts. Furthermore, here you see the date-time format. Here you see like how date-time values are supposed to be handled. And here you see I keep it a string, and that is pretty specific because you can also say, hey, how do you want to map goods, binary or string? I keep it on string. So you see you can fine-tune how FireDAC is supposed to treat your database. It's not the other way around. I mean, indirectly, of course, it is the other way around because at some point you might write to the database, but most of these settings are how is FireDAC supposed to interpret the values that are inside of my database. And most important thing is the string format. So if you go there, you see, is it Unicode or ANSI? Because I picked varchar, it is ANSI, you know, but you can force Unicode by setting it to Unicode. And these are things I recommend look it either up in the documentation of FireDAC, or of course I can wholeheartedly recommend the book by Kerry Jensen on FireDAC, which explains all these things in great detail. Of course not Sqlite specific, but FireDAC specific. So you learn all about the different means how to influence your connections. There's temporary connections, there's persistent connections, and Kerry explains all of that in great detail. The documentation explains it as well, but Kerry, being the master of FireDAC, explains it in a way that it's way more structured and way more easily to follow. So leaving this connection dialog, this is all you need to do. What I also always do is, and I don't know why this is enabled by default, I set the login prompt to false. And then you can pretty much test your connection by flipping the switch from false to true, and that's all it takes to connect to a SQLite database. And looking at a query, we drop a Tftquery. You can find it on the tuple, of course, Tftquery. And by the way, there you notice how much I usually edit when I type, because I'm one of the worst typers on the planet, especially looking at other people that code a lot of Delphi. So the Tftquery is the component we need, and the connection is automatically being set to the connection that's on the same data module, so you don't even have to set this. And then again, you can double click it in order to go to the query editor. Don't go to SQL and click this. That will not give you the full property editor that FireDAC provides. I've seen a lot of customers do that. It gives you the correct property, of course. You can set everything you need to set, but if you look here, you have actually the possibility to execute the query right here and see the data inside of this window, and you get the structure that is being returned, and you also get instructive messages what you could do better, I guess. And another key feature here in this dialog are the parameters that you can set for design time testing purposes. That's amazing. And of course macros, which I never heard of before FireDAC in SQL statements, because we all know that you can use parameters for in where name equals, and then you do colon name. The name is the parameter, and in your code you can set a value for name. But as soon as you want to do that for something like the table name, for example, if you were to write from colon table, that would not work. And the reason for that is that that is not a parameter, that is actually a macro. And a macro or macro, you use the ampersand, and if you use the ampersand, you see that this appears here right away, and you can set the data type and you can set a value. Okay, so you not only with FireDAC have variables for the comparisons and stuff like that, you actually have variables, so-called macros, for anything else in your SQL statement. And I say SQL statement, this has nothing to do with SQLite, this is a FireDAC feature. But let me correct it to states, and from states order by code. And just to give you the example where code equals code, it doesn't make any sense, but I just want to show you here the colon code, and immediately you get the parameter here, and you can set if it's an input parameter, output parameter, so you can test your queries at design time pretty well with FireDAC. Okay, that makes it much easier, or much more comfortable than what we're used to previously in Delphi. Even Delphi improves now and then, even though it was, I mean, database functionality in Delphi has always been amazingly well done. But with FireDAC and these tiny little things, it becomes even better. So this is select state code from states. We've looked at the database, we order it by the code, and if you execute this, you see all the states, and I selected the fields that are supposed to be selected, and that's that. Okay. The other query, I can actually explain it right away, and there you see that I don't cut this. I said I might not. Actually, it makes sense to do it. The date limits are the limits of the dates that we want to offer. If you remember, let me close this again. If you remember, in this dialog right here, we have a date time picker. And this date time picker has a minimum date and a maximum date. So you can make sure that the user doesn't select a date that is not available. You know, your user interface should always be smart. And that gives you the option to specify something that makes it impossible for the user to pick something that is simply not available. So you need to pick, or we need to pick, the first date and the last date in the database, right? And for that we have many options. And I looked at max and min, and those are all valid queries. But what I found out is that actually the quickest query you can do is just pick one record, because if you always just return one record, that's quicker than calculating the maximum and minimum, right? So what I did is, and let me tear this apart so you can read it easier, I created two statements. We select start time from incidents. Okay, so that's the column start time, which we just saw, and we order by start time and limit it by 1. So if we do this and switch over to the database tool, database, the incidents, and here we go to the query window, and we go to the incidents database, we execute this, and you see 3.5 million records still takes a long time, but here you see we select start time from incidents like this. Now that I'm showing you this, I just realized I didn't update my query after adding the database field for the date, so I can actually replace start time with start date and order by start date. So this should improve performance. And yeah, it did. It's instantaneous now. It was like 2 seconds, 1.5 seconds, and now it's instantaneous. So let's copy this, and from here I'll move it over to Red Studio, paste it in here. And the key is also the limit by 1, right? Because if you were to leave out the limit by 1, let's just do like 100, just you get 100 days. Limited by 1, so you only get the one date you're interested in. And interestingly, I'll be honest with you, I had to record this twice because I kept pressing F9 and in order to execute this query, but F9 actually stops the recording mechanism. So that was kind of interesting to fill this gap in again. So copying this into Delphi, which we just did, and here the same thing. Like we copy it until from here to here, and here. And the other query does the same thing, just with a different sort order. So the last state is actually first, because if you sort descending, so the one that is returned is actually the last. And the trick that I'm also using is I'm creating a select statement, which only selects the result of 2 select statements as its field. So if we execute this, we get first and last as the 2 field names, and only one record with the first date and the last date. And now the most important thing that I always miss with FireDAG. So they give you this nice cross here up in the corner to close the dialog quickly. Well, all your changes you make in here are gone if you click here. So you have to make sure you click OK. Otherwise, all the changes are gone. And it actually happened to me a couple of times that I was quite surprised that my SQL statements weren't working as I expected them to work out. And the reason for that was pretty easily explained to you looking at the editor again. But here you see everything is in place. But let's say I make this change, click on the cross. It's not saved. I mean, it's expected, but still, this OK button is so well hidden. I miss it all the time. So now that we're done with the database part of the application, we can actually swing over to the main form. This I'll really build from scratch. So I'll remove this from the project and start with you again. So at this stage, we have the data module in the project. And if we open the project forms, we should also see there's nothing here. So I'm really not cheating you of anything. So file, new, and other, we are going to add a form. Let's see where we have that. That is something, I don't know when it was moved, but it has gotten really complicated to find a form in here. I mean, it's right here. As far as I know, let me show you, you can right click here, add new, and there's VCL form. Much quicker. So here's the form. Let me drag the object inspector right there, and I'm going to name it form main. And the font, that is something I got into the habit of doing, the Droid Sans Mono, because it's a font that's freely available. And I'm getting older. The font size 8 is a little bit tiny for me. And the caption is browse accident incidents. Okay, that is what our form is called. Sizable is fine. Everything else is fine, I think. So we save it, and then we should get the dialog. Forms.main. I'm really overwriting the old thing. I mean, I must be crazy, huh? Having a perfect application and deleting it. Well, of course, version control. So I could always go back to what we had. So let's keep things simple. Drop a panel, do the thing we all have to do first. Delete the caption, delete the outer and inner bevels, and align it to all top. Make it a little bit bigger. And then we need 2 controls. One is the DB lookup comma box. Make sure you drop it inside of the panel and not outside of the panel. And then we need the date time picker. And I use the Advanced datetime picker, of course. And you see it's getting a little bit big, so make sure you right away select that you want to, the date mode combo box is fine, but datetime is also fine. There is a property where you can say, hey, I just want to use it for dates, I don't want to use it for time. Let me look for that. It has to be here somewhere, here, kind. So you set that to DK date, and voila, it's just the date now. And then we need the button to say, hey, please look this up. We don't want to make this automatic or trigger it. And for that, we pick the glow button component like this. And we name it button query whatever you want to name it. The caption is more important. The caption is going to be show incidents. And nothing else has to be set. Of course, you could add a vector image and all that kind of stuff. We're not going to do that right now. And what we do first is we name the components. So this is the combo box for the states. And this is the date time picker, DP day or date. Okay. So remember, we built the data module so we can set up the date time picker pretty quickly using what we set up in the database controller before. So double clicking on the form, you can say dp date.minDate. MinDate is what? DB controller, right? Remember, dot, not working. And this is very important. Of course, we have to add the modules database to our unit. So when we do that, we now have date first, date last, those two properties, date first and dp date max date, db controller date last. I think that's pretty amazing. And that's why I love Delphi, because you can really, I mean, everybody will say you can do that with any other programming language as well. Yes, of course you can, but I just like the data module with the database components, how nice that is. So let's compile this, still compiles, and the error insight will update as well. This is 10.4, so I can actually leave error insight on and don't have to disable it. And we can close this. We don't need this anymore. We can focus on the main form. So the final component we need, if we type maps, there's the FNC Maps, which is for all mapping services. You know, if you drop this, then you can go to services and then you can pick the service you want. But Google Maps has a specific functionality, the clustering functionality that we want to use. So get rid of this, maps, and pick FNC Google Maps, which is derived of FNC Maps. Click here, AL client, and name it map. Good, perfect. What we also need, because it's a Google map, we need the API key. So up here, we need to specify an API key so we can use it easily. I'm going to do that, and I'm going to cut it because I don't want you to use my key. So after setting the key, this updates automatically. What is very important to note is, not very important, but this is something I put a great focus on in my book. So how to create a configuration file that you can store your keys in. Those keys are being encrypted. You can even deploy them to the customer, because right now the key of my control, if I do this, it's right in here. And this is something people can read out of the resources of your executable. So I wouldn't put it like simply as an API key into the resource of the form. I would always encrypt it in some way and decrypt it at runtime. So now that we have the map in place and we have these controls in place, the next step, what we should do is make sure that the states are actually shown here, because if we run this, I mean, we already have a pretty cool app. I mean, we can use Google Maps inside of a VCL app. So here we have our Google Maps functionality. We have all the additional features in there that you can do the street view and do all that sort of stuff. But the actual combo box doesn't have the states. The date works. If we go here and click the year, see the year is actually 2016 to 2020, so that works just fine. So the dates are being set as we do in code. So the create form event is triggered. Nothing happens here because we didn't implement that yet, and the states need to be filled in. And I use the lookup combo box. I'm going to abuse that component a little bit, or that control a little bit, because Of course, usually it's supposed to look something up, and the value that you look up is supposed to be placed in another data set. And that's not what I'm going to do. I'm just going to use it to display something and then provide the selection to our runtime environment. So we can say, hey, Florida is selected. That means the code is FL. And in our database query for the incidents, we need to use FL, or we need to filter for FL. That is what I'm going to use it for. So first thing first, we have a data source and a list source in that component. And what you need to use is the list source. We only want to display something, list it. We don't want to affect any data source, make any changes. So these are the only properties that we'll need. And it's empty because we don't have any data source yet. So what we can do, we open up the module again. So that's there. And we add a data source. And I add it right next to the comma box, so I know that the comma box is tied to that. And I'm naming it DS source, DS states. And the data set for that, if the Delphi gods are with me, there we go. There we have the two queries, Q states, and there we go. So now we have the data source tied to the query, which is in the data module, and in the states component in the combo box, I can say, hey, the list source is DS states, and the list field is state, because we want to list the states, and the key field is code. Okay, so we save this, run this, and as soon as we select, for example, let's say we select Florida, the control sets the key field value property. It's not key field, that is a little bit misleading. So key field value is the property name to FL. So we always are able to access the code for the state that the user selects, okay? And it's really all the states in here. We just have to make the field a little bit wider so that all the states are properly shown. Okay, so we have the functionality to select the state, we have the functionality to select the date. Now we can already start implementing the show incidents button. Really, it's the progress we make is amazing, and it's all because of the ability to tie database elements to controls in Delphi, and that we created this data module so we can get the restricting information for the date picker and stuff like that. So show incidents, and this simply will call a function show incidents. That's what we will call the function. And show incidents will get what? Yes, of course, for a date, right? And for a state. So we say dp date. And of course, for a state. What is the state that the user selected? And that is comma box state dot key value, not key field, key value, okay, which is a variant. That's it. And we can now define show incidents procedure, show incidents for a date, t date, and a state that is of type string. Probably we should check if a state is really selected, or what we could also do is we select the default state when the application starts. You can do any of that. We'll focus on the map generation. So there's some things to remember. So I usually, of course, would start by explaining the variables to you, but we're really building this from scratch. So I will add the variables and all that kind of stuff while I explain the implementation to you. And the first thing we need, and this might be crazy, but the first thing we need is we need the format of the date, because I explained to you just in the beginning of this very session or very video that Sqlite needs a different format. Sqlite needs 2020, needs it like this, 07/23. This is today's date. And this is the month, this is the day, and these are the year. Nobody writes dates like that, but Sqlite does. A lot of database servers do. And that is what we need to generate. So we need to get the format settings from the VCL, declare format as our tformat settings variable. And lformat has a property which is called short date format. And there we can set the format we want. We want year, month, and date separated by minus. And with that, we can actually convert the date that has been provided to us into the string that we need for the database. So with that said, tl_date_string, type string, l_date_string equals date to string and a date, because we passed it. We're not accessing the. This could actually go into a separate class if we wanted to, because this usually would not go into the form class. This would usually go into separate controller class. But for the ease of this demo, let's keep it in the same class. And of course, date to string can get, here you see that, tformat settings. Otherwise, it's going to depend on your on the settings in your system. That's not what we want. We want this specific format, which we set here. So if you wonder why I didn't do a try finally for lformat, even though I call create, tformat settings is a record. So we don't need to free lformat. Lformat is a record. We don't need to free it. And this is fine. And with that, we have the date in the format that we need. And the next step is to create the query. And for that, we create an instance of Tftquery. And now the thinking starts. This shouldn't be in the form class. Same reasoning as with the show incidents. That's why you put it in a different class, because now I would have to add like all the units to my users class that are FireDAC specific for the query that I usually want to keep separate from my user interface. I'm going to do this adding units in Delphi. If you don't know what you need to add, is pretty simple. You drop it on the form like this. You save the form and you remove the component again, because now that way all the stuff has been added to your users class that you need actually from here. So those are all the units that you needed to add, and these are all the units that are very FireDAC specific. So if you were to use this form, this main form, in another application and you wanted to use another database framework, you would make it very difficult by putting show incidents into the same unit as your form. So this probably, if you were building it for a real world case, you should probably put it in a different class. And with that said, you see that Tftquery is defined now, and we can create it. So Tftquery.create. We're not going to define an owner, meaning we have to release it ourselves. Try app tab. And with that said, we free it in the end after everything we do here. What are we going to do? We are going to define a connection. And where do we get the connection? Of course, from DB controller. And then we also need a SQL statement. And where are we going to get the SQL statement? Well, TSQL statements is the class that was defined in the data module right here. And it's a class function. So we don't need to do TSQL statements.create. We simply period and say get incidents. And that will get us the SQL statement. So you see, we don't, even if it were in a different class, we do not meddle with anything database specific. So we can concentrate on getting the data on the form, or on the map, I should say. And now we can set the parameters, because we have two parameters. One parameter is date, which is the date that is supposed to be selected as string. Of course, we have to use as string because we converted it in this format, which for Delphi is not a date. And then the next one we need is the code, which is the code of the state. It's also a string, and that is, of course, a state. Maybe we name this parameter a state code, so that if we look at this code again in 3 days, because this is usually the time that I need to forget these things, then we can do this. So we have an error here. I said dp date. Of course, dp date dot date is what the user selected. Okay, so show incidents dp date date, key value is being passed to show incidents, and then we have here the state code as the value. So the parameters of the query are filled. We can now actually open the query. At this point, we have all the incidents on the day in the state. That's it. And now you can really already say, hey, we can iterate all the different incidents if we were to show it in a grid, do whatever. But there might be the case that on that particular day, we're not talking about Florida here, haven't been any incidents on the road, accidents. So there's actually, if you, for example, browse Massachusetts, there's more days where there's no accident than days there's any accident. So you check real quick, queue incidents dot record count bigger than 0, then we want to do something, and otherwise we just want to inform the user that there haven't been any accidents. No accidents recorded for selected state on that day. That's a pretty informative message. Empty information. MB okay. 0, that's that. Okay, so that's fine. Let me just say a word to record count. Record count in this case, it might be 5, 10, 15, 50, 50, 50, or 50. And I'm not going mad or my record is broken or something like that. That is actually something that is very specific to FireDAC. 50 is the amount of records that Sqlite is going to fetch in one go if you call open. So if you can still traverse your record set, but FireDAC is so smart that it only requests a certain number of records at a time, which you can configure pretty detailed, and that leads to issues with the record count, because the actual records received from the database server, or read from the file in this case, are only 50 at max. So using record count is always a little bit dangerous in FireDAC. But in this case, we just want to know, is it more than 1? Is it more than 0? And then we're good. So I can neglect that record count is not actually the number of total records that match the criteria of the query, but I just want to know if the data set is empty or not. So that is fine. Otherwise, record count is not reliable unless, and this will be a little bit of browsing for me. This is something that I would usually, when I wasn't doing a hands-on, I would prepare. I think it's in the fetch options, and wow, I found it right away. Record count mode, and you see CM visible. It's set to the records that are visible right now, and if you really want to make sure that the record count mode means it's the total number of records, just be very careful using CM total, because in this case for this database that we're using right now, select count star, not 8, from incidents, that is actually what would happen. So that is what FireDeck would do if you said, hey, give me the total number of records. And it would do that immediately after each, I don't know, I would think after the query is executed, basically, or if you access record count. So let's run this. And it's actually pretty quick. It only takes a fraction of a second for 3.5 million records. But believe me, if the database set becomes bigger, this might take significantly longer. I have a separate example in my first hands-on book where the count actually takes more than a minute, and you have to use some kind of helper in order to determine an approximate value for the record count. So count star can actually be a pretty costly operation, so use with care. Good. Going back to the example, record count bigger than 0. If we have that, if we determine that it's more than 1, then we can actually start making changes to our map. And before you do anything with a map that is more than 1 or 2 operations, you call begin update. It's kind of like dataset begin update, and that you freeze the painting operations. Otherwise, the flickering and the whole process will become slow. Begin update, and of course, make sure that you release it again. Even though if something goes amiss in the middle, you want to make sure that end update is called. And with that all said, you can say map markers clear. So any markers that have been set on the map before are being removed. Rectangles, we're going to paint rectangles. Okay, so we also have clear rectangles as a method. Do we also have clear markers? Yes, we do. So this is so great about TMS. They had new stuff all the time. The last time I looked at this wasn't available. And so kudos. It makes it even quicker. And do we also have clear clusters? Yes, we also have clear clusters. Perfect. So anything we might have happened before, because the user can select a state, and then the user might select another state, and then we don't want the old information on there. Makes sense. So the next step, after we basically cleaned our drawing surface, is to actually traverse the data set. And we know that since Delphi 1, the query while not UIF, good one, do begin. And the last one, I write that first all the time because I always forget it, LQ incidents next. And we also need a cluster where we put everything into. So we actually create a cluster and map clusters .add. This is 10.4 specific. So what I'm going to do is I'm going to add the cluster on top TMS FNC. So it's a component from TMS in the FNC network from the maps, and it's not the maps component, it's the Google Maps component, Google Maps cluster. See, perfect, huh? That's how the type names are built. L marker is going to be the marker that we use, TMS FNC Maps marker. It exists right here, see? But we use the Google specific marker, FNC Google Maps marker, also a class. So that way you can build the types that they specify. We also need a rectangle, L rectangle, TMS FNC. Nothing special about a rectangle for Google, so maps and then rectangle. Perfect. There we go. And we need the start coordinate, and we need the end coordinate. Remember, in the database, going back here, looking at the incidents, you see we have a start latitude, start longitude, and we also have end latitude and end longitude if the police department marked the area that was affected. So that those two coordinates, and for that, TMS has a TMS FNC Maps coordinate. At least I thought it was called that. TMS FNC Maps. Yeah, coordinate. It's up on the top because I changed the display resolution. The code completion hasn't caught up yet. I thought at least. TMS FNC Maps coordinate rec. Yeah, that's the correct type. And if you're stumped like me, why this type isn't there, and it should be, it's pretty simple, because the type, of course, is in a unit, and because we only added the TMS Google Maps, the types are not there. So we have to add the correct unit that contains this type. The same is probably true for the helper functions that we need, create coordinate and all that kind of stuff. So we need the unit that contains that all, and if I remember that correctly. So the unit, I had to look it up, I'm honest. I'm not going to make a big fuss about it. It is TMS FNC Maps common types. Of course, it's mentioned in the documentation, and in this unit, you get all the common types that you need to work with maps, and you also get like utility functions. All of that is explained in great detail, and there's nothing worse than personal advertising in books, of course, in videos, of course. But if you go to my book, there's common types and utilities, and there's a whole subject just dedicated to these types and utility functions, how you can use them and how they can make your life easier. So we added a cluster, we have the coordinate, also mined coordinate rec. So we're going to use record types. That is something TMS made a perfect choice to offer both records and classes. The classes, of course, have some, or objects have some advantages, but if you just need to provide a list of records, for example, without anything that an object offers, the record is faster and you don't need to manage it, because the record, of course, is one of the so-called managed types in Delphi that you don't have to free manually. So a record is definitely an advantage here. And going from that, let me think if I forgot something else. Of course, it makes sense to copy the database fields into variables. So we have the start latitude, start longitude, start end latitude, and longitude. We have all those double, and with those four, I think we're looking pretty good. I think we have everything covered. Good. So going back into the loop that is iterated for each record. So we actually start latitude is LQ incidence field by name. And what is the field name? Well, look right here. In the tool, in the database tool that you use, we have start longitude. They use LNG. I've never seen that abbreviation. I always use LON, and those are the field names we need to use. So here we say start underscore latitude, and we want it as float. And the same thing, copy paste. Yes, I'm lazy. in case you didn't know, ln, and here we do lng, and now I do something that is even worse. I do end longitude and latitude and latitude and longitude. Perfect. And those are just the values from the fields, right? So right now we have these values in those double value variables. And what we can do now is we can create a coordinate record. So the L coordinate start, okay, is, and for that we have one of those helper methods that TMS provides, create coordinate, where you provide a latitude and a longitude, and L start lat, L start long, that's coordinate number 1, and coord E for end coordinate, create coordinate, L end lat, L end long. So perfect. That's it. So we have our two potential coordinates. I say potential because the end coordinate is not always provided, because sometimes it's just something, you know, an incident on the road where no area is affected, so the police department is only going to give a start coordinate. And we can add the marker to the map now, so we can say L marker equals map add marker. Okay, that is the method that you can call either with latitude, longitude, and a string, or a coordinate. So we created the coordinate, so we can use it, lcord s. We're not going to use a title or anything. You might struggle when you use it like this and compile that TMS FNC Google marker expected and maps marker, they don't match. Well, we use the add marker method from the map control that is inherited from the control that is suitable for any service. But it is overwritten and now returns a Google specific marker, or that way we declared our marker as a Google Maps marker. So what we need to do, or can do, is we can simply say TMS FNC Google Maps marker. This way it'll be nil if nothing was added, and otherwise it should work. Yeah, it does. So, and now we can set the cluster of the marker to the cluster that we created before. And something else we can do, I might be so brave and do a second part of this video that shows you how you can interact with the elements on your map. If you click on it, open a second dialog. I might be so brave. So we store the data, we store the ID from the database that this flag or marker belongs to as a reference in data integer. So here we do ID as integer. So if we look at the marker objects later on, and then the user clicks on it on the map, we can access the property data integer and retrieve the ID of the field in the database and get all the additional information that we might want to show on a detailed dialog. So that's that. And the marker is already on the map because we called add marker. That's exactly the reason why you have to call begin update, because if you don't, at this moment it's being painted on the map, then it's changed again. So these would already potentially be 3 changes to something that should not be drawn really and shown to the user yet. It should be shown when everything's done here at the end. So that is how much work we are going to put into the marker. At this point, of course, we can run it and see what happens. Oh, I forgot one very important step. Oh, did I? No, it's all good. So Florida, and let's pick a date like this. Show incidents. That was quick. Let's see. Here we go. And there you see we have quite a few accidents on April 22nd, 2020, and the clustering works perfectly. So you can for example, if you go to Jacksonville, you click on Jacksonville, and then you see the cluster with all the different markers in there. You click here, and you see that there's quite a few accidents in that area if you zoom out. Okay, so now the last thing we want to do is we want to draw the area that is affected as well. We just don't simply want to show the markers. We also want to draw the rectangles. But the rectangles are only supposed to be drawn if there is actually data in the coordinates. So we can check the if L chord E, and as far as I thought, this is the difference to the record and the class. The record only has longitude and latitude. If you were using the object instance, you could also say is coordinate empty and do stuff with that object. Right now it's just data storage. So the only thing we can do is look into the values, or we use that is really preference which one we use now. Chord E dot longitude not 0, and chord E latitude not 0. Then we can draw an area, and an area always is drawn with bounds. Bounds are left corner, left top corner, right bottom corner, kind of like in the VCL when you draw a rectangle. And this rectangle, we declared it. There, as you might have figured, we have the map control, and the map control has a method called add rectangle, and it needs bounds. Bounds is what it's referred to if you have an area, and for that, yet again, you have a helper method, create bounds, and it offers a gazillion overloads. The one we need is that you have two coordinates, and you see here coordinate 1, coordinate 2, so you can easily create the bounds calling L chords S, L chord E, and that's all it takes to add the rectangle. So right now there would already be a rectangle on the map, but we want to color it according to the severity of the incident. So we also declare L severity, integer, and read it from the database. So L severity equals LQ incidence, field by name, hopefully, severity, and as integer. And we can build a simple case statement for that. L severity, and please allow me to do a copy paste, because that really is something that does not need to be explained in my opinion. If the value is 1, we set the fill color of the rectangle to CL green, olive, yellow, red, purple. So the higher the severity, the higher the more reddish or purple it gets. And if it's any other value, just in case, you know, with databases and data consistency, we set it to white. And this way you can customize your rectangles. You have other properties in there. For example, you can set the opacity, that it's not completely drawn over the map. So I would pick a value like half, you know, half visible, half transparent, and that's it. So now we also have the rectangles on the map. We run this. There we go, Florida. And again, 4/22 was the date that we had. That was a good example. So that's it, and nothing is moving. You know, you don't really see that something happened, right? We're gonna fix that in a second. So we scroll out, and there we go. See, oh my God, 100. See, and this is how red it can get. Woo, 203 accidents. And you see those tiny little things here. If we go to Tampa, for example, there you see a whole, this, of course, it makes sense, right? You see that the data is actually correct, because if there's a traffic here, the whole bridge is going to be affected, you know? So that works pretty nicely. Or here, if there's something here, everything. So you see the rectangles are drawn according to what is in the database. This was just a minor accident, but still the whole area was affected because of it. and yeah, quite a few accidents that day. And it works nice, but what I don't like is the fact if we're in Florida and now I look at Delaware and I'm still in Florida and everything's gone, obviously. But so what you can do when you're done, you say map dot zoom to bounds. You zoom to the area of points that are interesting to you, and bounds, there's nothing easier to do if you have map.markers, which is a collection of markers and a property of the mapping control. And then you can say markers dot to, and then you get all the methods that allow you to convert this collection to something that you can use with other utility functions of the FNC Maps framework. And there you see JSON, of course, you can get it, you can save it, but the best thing is you can get it as a coordinate array. And if you look at the overloads of the zoom to bounds, there is actually a coordinate array right in here. So that is exactly what you need. Close it off, and with that one single line, you're going to improve the usability of the application immensely. So what you're going to see here is, if you go back to Florida, 4/22, show incidents, and now if we, oh, it already happened, right? Like, you go to Delaware, we are in Florida, we go to Delaware, whoops, and the map immediately changes over there. So that kind of little function makes the usability of the whole application so much better. Good. So guess what? We're already done. We've built this amazing application in a little bit over an hour, and it was pretty hands-on. And just, I mean, I have to do a little bit of advertising for myself. It's coming out real soon. It's going to be a book just about FNC Maps, and it's going to tell you how to install it, how you get started. It's going to look at the core utilities of the FNC framework. It's going to explain all the common types of the FNC Maps framework. It's going to go into detail of all the shared features that the mapping it offers for all the different service providers that the mapping framework offers. So for Google, TomTom, Bing, Azure, OpenMaps, all these services share these, and this is the big chapter 7. Please don't pay attention to the page numbers, because I'm still writing the content, especially here. There's a lot of stuff missing. So geocoding, of course, geolocation, and then these Google Maps specific controls that we just looked at. Right now we're at 330 pages. I expect it to be around 400 pages when it's finished. And this example is just something I found out about in the other day, like the data set I found, and I said, well, this is a perfect example for clustering that would make a good test case for FNC Maps and would show so much more of the power of FNC Maps, how easy it is to build very good visualizations of map data in a very short time. If there is demand, I'm going to do a second one that will tell you how you can interact with the clicks on the markers and open up a pop-up or a dialog. But that depends on the response of this video. If you guys like this format of the hands-on format of the videos, a little bit less formal, but more practical, more hands-on. Enjoy working with Delphi. See you soon.